that view. Thank you.
That's correct. If you go to view everyone on top, and you can pick, and in this case, active camera or who's talking would be a way to get the main screen. Here I have one of our apprentices, Gabriel. He's going to show us the Mechatronics basic motor control trainer and what he's learned. Can you introduce yourself, please?
Yeah, good afternoon. My name is Gabriel Gomez. I work for OneWeb Satellites. I want to show you a circuit that I have here with an electric motor to show you the different setups that can be used in the manufacturing. So this circuit is called reverse starting with jogging. What does that mean? The jogging means that as long as I press a button to activate the motor, it will stay running. But if I release the push button, the motor will stop. That can be used in companies that need to do a certain job that doesn't require too long. So the person can just press it, do whatever job is required, and then release it, and the machine will stop. So I'm going to show you now. You can see if I release the push button, it will stop. So an operator is required to be in front of the machine as long as they need to do the work. We also have another option to make the motor run continuously without having an operator be in front of the machine. So now the motor will keep running as long as you don't press the stop button, of course. So if I press the stop button, it will start the motor. But as you can see, even with that, it takes a long time for the motor to stop spinning. So we have another way of making it stop faster. We can use the reverse push button to make the motor go in the other direction and make it stop quicker. So to do that, it has to be in a specific time, because if we keep pressing the button after the motor stops, it will start running in the reverse direction. So we have to do the same thing, but with the forward button. So that will be all.
Thank you very much, Gabriel. Now we're going to move on to meeting some of our other apprentices. And here we have Dominic. Can you tell us a little bit, Dominic, about what you're working on and what this trainer has taught you?
Hi, my name is Dominic Howell. I work for OneWeb Satellites. And here we have the hydraulic trainer provided by Festo. And basically what I'm going to do is I have a circuit set up that I'm going to use to crush this can. Okay, so this is something that is used in various industries, as where hydraulic is something that is widely used. So I'm just going to turn it on for you. Put the can in. And it's crushed somewhat.
Excellent. Thank you very much, Dominic. Wow, that was wonderful. We try to find real applications in life as the students go through the different trainings. Now, what we have right here is Caroline. Can you tell us a little bit more about you and the training that you've been doing?
Yeah, so I'm Carolyn McGowan. I'm with OneWeb Satellites. I started this apprenticeship right out of high school. And today I'm standing here with our Festo pneumatic trainer. So this is a simple circuit that's set up from the compressor. It goes into the manifold. And the manifold, it goes into 3 separate push-button valves. They're all 3-2 valves, normally closed, push-button actuated, each one going to a different component. So the first one, you can see, will actuate the cylinder, allowing it to extend and then retract if it's released. The second one goes into a motor, which you'll see it spin, and then when the push button is released, it'll stop. The third one actually goes into a vacuum pump, and doing so creates a vacuum in this section, allowing me to pick up this golf ball. And then when I release it, the golf ball will drop. So obviously this can be used for many different things. The suction cup, for instance, can be used to move a component from one place to another depending on what you need for the manufacturing process.
Thank you very much, Caroline. Let's go ahead and move on. We're here into our CNC slash robotics section, and here I have Tarun. Can you tell us a little bit about what you've learned and what you're doing?
Good afternoon. My name is Tarun Kumarville. I come from Lake Mary High School, and I work at OneWeb Satellites. Here I have a 3-axis CNC machine, and I'm going to show a demo of the machine.
Excellent, thank you.
So this machine can be used to make aerospace grade parts, whether it's out of aluminum, steel, or titanium.
So next we have Kate. Kate has done an amazing project this semester, and she will be showing us a special automated machine. Can you tell us a little bit about you and what your project's all about, Kate?
Hi, I'm Kate Borelli. I work for OneWeb Satellites. And during the summer, when I was between my 2 jobs, I built a pneumatic lift onto a prototype of a surfboard mold blank. Now, a surfboard mold blank is really just the foam part inside that really makes you float. So if you press this button here, used for safety, it's a dead man switch, and push it up, it'll slowly rise open, and you can pour in your AV components for the foam. And then as soon as you're done, you can just press the button again, push down, and it will close a lot faster so that the compression can get the foam, which rises extremely fast.
Excellent. Let's move on to some of the materials that can be molded.
So these are the AV components that are used for the foam. They mix together, and at a ratio of a 66/100. They act almost immediately together. This is one of the original foams by Clark Foam. The purpose of the foam is that they want it to be really white, more aesthetically, but it needs to stay white. Now, this is from 2011, I believe, and it is still extremely white and really perfect. And each of the foam is very close-knit cells so that the buoyancy can be correct. Now, these two were mixed and created this foam. Now, it's slightly yellowed, so it's not really something that you would want in a long run just because of aesthetics. And this one is too flimsy. This one is a little too rough, but it's got closed cells like you would want. And these cells in here are very broken up and very large, so that's also not something that you would want. And so that's about it.
Thank you very much, Kate. Now we're going to move on to some of the skills that you also learn, and we'll go back with Caroline. Caroline, can you tell us a little bit about the trainer that you have here and what you've learned in there?
Yeah, so sitting here, I have the AC/DC trainer that we've used. So this goes through basic components such as transistors, motors, resistors, capacitors, how they can be used, such as how to wire single pole, double throw, and various different types of switches and buttons. So here I just have a little visual demonstration. When we turn it on, the double pole, double throw switch is on A, and the 2 indicator lights light up, and this is all just through DC. When we go to B, the green light lights up, and the DC motor turns on, and you can see it visually with this fan. So this is just one demonstration of what you can do with this and what we've done in the past.
Thank you very much, Caroline. Let's go ahead and move on. to actual hands-on. And right here we have an ongoing project right now. And in this project I have two of our awesome students, Eric and Christian. Can you tell us a little bit about your project and what you've been learning, please?
Hi, my name's Eric Osmondson. I'm the apprentice for Rocket Crafters.
And hi, I'm Christian. I'm the apprentice with Knights Armament.
So the trainer that we've been working on is kind of the next step from the A-frame trainers that you just saw earlier. It's pretty much an introduction to enclosures and conduits. And you're pretty much going to be doing more of the hardwire stuff now. Eventually, when this is done, it's going to control a DC motor that's going to open and close a door that you see here. Right now, we don't have any of the wires run yet, but that's the end goal.
Yeah, and this trainer has actually been really cool because it's the closest thing we've experienced so far to actual on-the-job training. While a lot of the other trainers are a little more theoretical, this is a lot more hands-on, like what we would see in the work environment, as in actually assembling, punching through metal, drilling, cutting metal pieces to size to be able to get the job required done, and planning out certain schematics, reading blueprints, checking out part numbers, just a lot of really useful experience that can be taken into the workplace. And the actual concept of it with the actual hard wiring and stripping everything is going to be a real neat skill to have, especially when you check out the safety systems involved, like the limit switches to cut off the circuit, to automate it a little more, along with the controls. Overall, just really useful information to have on deck and to help boost the skill set that we can offer.
Excellent. Thank you very much, Christian. I hear the robot calling us. It's working now, so let me take you back. Everybody strapped. I'm going to go a quick run down to see our Kuka Robot. Excellent. Well, Tarun, tell us a little bit about what you learned about using the Kuka Robot. What kind of skill sets?
So with the Kuka Robot, you're able to learn how the axis works, how to pick up a part, and how to program the robot, and to move a part from one place to another place safely, slowly. It's mostly used in the automation, so it can also be used as a welding robot, usually used in the car manufacturing. So it'll be good skill sets to learn how to program these robots and troubleshoot and maintain them in the factory.
Excellent. Thank you very much. Now, let me take you back to one of our capstone projects that will be involving our students this semester, and that's our MPS station. Right in front of me, we have our Festo MPS Station, which is a demonstration of the capabilities of automation. Right here I have this small plastic that represents a product, and students will be able to learn about conveyor belts and be able to move these pieces, about sensors, and I'm going to activate it so you can see how that piece moves from point A to point B. Now I'm doing it manually, but the students will be able to use this capability to move this part from point A to B and go through the sensor and be able to put it in another conveyor belt. And right here, pick up at this next conveyor belt, pass through the sensor. Inside of this product is an RFID tag, and this RFID will be able to identify the product, where it's been in the production line, and give a real-time information. And that's what it's all about Industry 4.0, being able to manufacture parts and know exactly where they are in the production process. students will be able to learn not only about that, but also be exposed to automation, robotic arm, using pneumatics, sorting station right here, and so forth. All of this is powered by a very powerful program through Festo that they will be able to order what they want in the products. That concludes our Mechatronics lab tour. Thank you everyone for coming today and being with us. Now I'm going to take it to Frank because we got other labs to go to. Go ahead, Frank.
All right, thank you, JP.